Today we will be going over lesson 21. The key terms for this lesson are theoretical probability, which is based on what we know about the situation. For example, the theoretical probability of getting heads when flipping a coin is 1 over 2. And it's because a coin has two sides. A regular coin, of course, has two sides, and one of the side is heads, and that's why we have 1 in the numerator. Permutation is an arrangement of things in a particular order. For example, when we are trying to find out how many different ways can first, second, and third place be given to runners, we want to use permutation. Factorial is the product of all positive integers less than or equal to that number. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is also equal to 20. 3 factorial is 3 times 2 times 1, and so on. Alright, permutation. Here's the formula for finding permutation. N represents the number of things, so the number of different outcomes. R is number of things taken at a time. So what are we looking for at a certain time? So take a second to write down that formula. We are going to be using that formula for this lesson. Alright, here's an example. This one is just to plug in numbers so you understand how to use it, and then after that we'll give you word problems. So we have n factorial over n minus r factorial. So what you want to do is take a look at what n is. Keep in mind that n will always be the bigger number. So in this case, it's going to be 6. So we plug in 6 where the n is at, plug in 2 where the r is at. We can simplify that to 6 factorial over 4 factorial. We can write it down, all the numbers like that, and then start crossing out. All numbers we have in common, top and bottom. So when we do that, it simplifies to 30 only. So over here, in this step right here, I'm going to show you how to do a quicker way. Writing 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1 can be time consuming. So what you could do is, on top, you could have just rewritten 6 times 5 times 4 factorial over 4 factorial, and then you could have crossed these out. So to know when to stop, you keep writing the numbers going down until you reach the smaller number, which is 4 this time. If it was, for example, 7 factorial over 3 factorial, then you want to write 7 times 6 times 5 times 4 times 3 factorial. You basically want to be able to cancel out, so just write until the numbers cross, and then you can cross those out. Then you would have 6 or 7 times 6 times 5. Alright, moving forward, I'm going to do it that way just because it's quicker for us. So here's another example. There are 8 people on a swimming team. The coach needs to choose 4 swimmers and the order in which they will swim in the next meet. So how many different ways can the order be chosen? So we need to identify our n and our r first. N is going to be 8 because that's how many we have in total, and r is how many we are taking at a time. We are choosing 4, so that is why r is 4. Plug in everything we know. That is going to be 8 factorial over 8 minus 4 factorial, which is 8 factorial over 4 factorial. Rewriting it, as you can tell, I did 8 times 7 times 6 times 5 times 4 factorial. We can cross out the 4 factorials, and we get 8 times 7 times 6 times 5. If you plug that into the calculator, you get 1680. So 1680. That's 1680 different ways the order can be chosen. Alright, now I want you to try one out on your own really quick. pause this video and then resume when you are ready. Alright, so again, let's identify N and R. N is total numbers, which is 5 finalists. R is how many times we're taking, or how many things we're taking at a time. So we have gold, silver, and bronze, which are 3 different metals. And that's why we have R equals to 3. Plug in everything we know. We have 5 factorial over 2 factorial, which is 5 times 4 times 3 times 2 factorial divided by 2 factorial. Cross it out and we get 60. So there are 60 different ways we can pass out the 3 metals. Alright, theoretical probability. So theoretical probability, like we mentioned earlier, is how likely an event will occur. We do not need to actually do anything to find the theoretical probability. It is based on what we know. So here's the formula. Theoretical probability is equal to the number of ways an event can occur divided by the total number of possible outcomes. So here's an example. A red number cube and a blue number cube are rolled. Keep in mind that just really means a dice. A number cube is a dice. If all numbers are equally likely, that means there's one of each number only, what is the probability that the sum of the numbers is 5? So the first thing we need to do is write down all of the list. So we have, pretend the first column is red, the second column is blue. So I write down all the different options, and if you notice, there will be 36 total. Now what we need to do is find the sum. Sum means to add. So we have 1 and 4. We have 2 and 3. We have 3 and 2, 4 and 1. And if you go further, you won't see any more that adds up to 5. So now the denominator earlier I mentioned was going to be 36 because that is the total number of possible outcomes. And the numerator is how many times can it occur. Well, we already did that and we got 4 in total. So we have 4 over 36. And as usual, fractions have to be simplified, which turns out to be 1 over 9. Alright, let's look at a different one. The spinner below, or to the right side, shows 8 equally slices. So we want to compute the theoretical probability of landing on white. So we mentioned that the total number of possible outcomes should be 8 because there are 8 different slices on that pie and it's all equal. There's a big reason for that. That means we have an equal chance of getting each slice. And on the top is the number of ways an event can occur. In our question, it's asking for white. So if you count, we have 1, 2, 3. So that means our fraction should be 3 over 8. Alright, now I want you to try one out on your own. Again, pause the video and then resume when you are ready. Alright, so probability of flipping tails. We know it's 1 over 2 because again, like I mentioned earlier, a coin has 2 sides, one should be heads, one should be tails. So the probability of getting tails is 1 over 2, or you are used to probably thinking 50%. same as 1 over 2. And the second one says rolling an even number. Well, on a dice, we have 1, 2, 3, 4, 5, 6. So there's 6 different numbers, and the even numbers are 2, 4, and 6, which turns out to be 3 over 6 or 1 over 2. And keep in mind that because we're looking for one thing and another, right, I mentioned and, we need to multiply the probabilities. So when we multiply, we get 1 over 4 as the final answer. So that means we have a 25% chance of flipping tails and rolling an even numbers, or an even number. Alright, permutation in probability. So earlier, first thing we did was permutation, second thing we did was probability. Now we are going to combine those together. Here's an example. Each student receives a 5-digit locker combination. What is the probability of receiving a combination with all odd digits? So let's take a look. Probability of getting an odd digit. So you know that numbers go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 numbers in total. And odd numbers will be 1, 3, 5, 7, and 9. So there are 5 odd numbers. We divide that by 10. That's how we ended up with 1 over 2. Well, how about the second odd digit? Should still be 1 over 2. It never said we cannot repeat. It just said 5-digit locker combination. So we keep doing that for all 5 numbers. I'm not going to write all 5 because, as you can tell, pattern says 1 over 2. So all we have to do is multiply each. All 5 together, and we get 1 over 32. Alright, so here's another example. Havana draws 5 coins from her coin purse that has 2 quarters, 4 dimes, and 6 nickels. She does not replace the coins after selecting them. What is the probability that she draws a dime, a quarter, and then a nickel? Alright, so total coins in the purse. She has 2 quarters, 4 dimes, and 6 nickels. That means 12 in total. So that should be our first denominator. So the probability of drawing a dime, there are 4 coins in total, or 4 dimes in total. So that goes in the numerator. The denominator is how many total possible outcomes, which is 12. Alright, let's simplify that really quick, and we get 1 over 3. We do the same thing for the quarter. Keep in mind that we do not replace the coin. That means now in the purse there are only 11 coins, and that's why the denominator is 11. And then the numerator is how many quarters there are. We have 2. So 2 over 11. We cannot simplify that. So let's move on to the nickels. Remember, again, we had 11 coins, took 1 out. We now have 10. Total nickels should be 6. So we have 6 over 10. Simplify to 3 over 5. So now all we need to do is multiply them together. Simplify some more. The 3 on top can be crossed out with the 3 in the bottom. So we get 2 over 55. That means we have 2 over 55 chance of drawing a dime, and then a quarter, and then a nickel. Alright, I want you to try one out on your own. Resume the video when you are ready. Alright, so we're only looking at all the balloons being green. So the probability of getting green the first time is a little bit simple, right? It's 3 over 12. And keep in mind, we're choosing them, so the numbers cannot repeat. So the second time, because we already took one balloon out, there are only 11 left. And because we took one green out, we should only have 2 left. Same thing for the third one, should be 1 over 10, because we only have one green balloon left after we took the other 2 out. So now we multiply all of them together, and we get, well, let's simplify first, I apologize. So 1 over 4, and then that one can go with the 4, or the 10, giving you 5. So we get 1 over 220. So that is the probability. Alright, geometric probability. So it's basically everything we've done before, except for this time we include shapes in them. Alright, so geometric probability is a form of theoretical probability determined by the ratio of lengths, areas, or volumes. So this goes back to your geometry class, so hopefully you remember how to find a volume of something, or area, and whatnot. So here are some examples of geometric probability that you might not do it in your daily life, but there are people who do it. For example, probability of hitting a bull's eyes on a dart, right? Or gambling, finding the probability of getting 0-0 on a roulette wheel, etc. or etc. Alright, here's an example. If the green circle has a radius of 4 inches and the entire colored figure has a radius of 10 inches, what is the probability of randomly picking a point in the pink region? So answer in decimal form to the nearest hundredth. So first, let's find the area of the green circle. If you notice, I wrote the formula. Area of a circle is pi r squared. So we get the radius of 4, plug it in, we get 16 pi inches squared, because area has inches squared. We have to square it when it comes to area. Alright, we have that. Now we cannot find the area of the pink region just because it's technically not a circle. It's part of the circle but not the whole thing. So right now we need to find the area of the whole circle, which is going to be pi times 10 inches squared, giving us 100 pi inches squared. To find the area of the pink, we can take the green and subtract it from the total, right? The total is the whole thing, and we should get 84 pi inches squared, because 100 minus 16 is going to give you 84. So now that we have that, we can find the probability. The total outcome is the whole circle, which had an area of 100, and then the pink region had 84, and that's why we have that. Type that into your calculator. You should get 0.84, which is going to be the final answer because they want you to round it to the nearest hundredth. Alright, I want you to try one out on your own now. Resume the video when you are ready. Alright, so find the probability that a point chosen at random inside the large triangle is in the small triangle. So again, we want to enter our answer in simplified form this time. So same thing as we did earlier, we need to find the area of each. Keep in mind, area of any triangle is 1/2 base times height. So we plug in everything we know. The small triangle has the base of 6 right here and the height of 10. So using order of operation, we get 30 inches squared for the area of the small triangle. I apologize. That should say small triangle. Alright, now we have area of the big triangle. Same thing, 1/2 base times height. The base for the big one is 9 right here, and the height is going to be 15. That's why we plug that in. Using order of operation, we should get 35 over 2. If you want to, you actually cannot simplify that, so we are going to leave that like that for now. So now we want to write the small triangle on top and the big one on the bottom. So 30 over 135 over 2. Keep in mind, we cannot divide by fractions, so we need to multiply by the reciprocal, which is going to be 30 times 2 over 135. Simplify that, dividing top and bottom by 15. Keep in mind, you can simplify first and then multiply, or you can multiply and then simplify. It's really up to you. I like to do it first so that I don't have to multiply by big numbers. Alright, so we have that. We end up with 4 over 9. So the probability of hitting, if we were to throw something or choose a point inside the small triangle, we get 4 over 9. Alright, so that is all that we have for today. If you have any questions on this recording, feel free to reach out to me and we can go over either this recording or anything in the course.